Okay, we are back. This is Techmath2. We are in chapter 11 in the red book, and we are looking at 11.3. And so we're working with sine waves, and we're pushing them out of phase. So phase differences between a fundamental and a non-fundamental sine wave. So in phase or out of phase are like in phase sine waves are fundamental, out of phase sine waves are non-fundamental. All right, so let's take a look at number 20. I don't really like how the book does this, okay, because they ask it in a weird way. So look, I graphed it. Sorry, it's still not great. You might want to look at number 20 in your book. It says on the graph above, the arrows represent the phase differences. So that they're showing the arrows, it pushed it 90 degrees. But instead of asking, you start with the sine wave, and then what does the one that I'm graphing, what does that plus 90 do? What it does is it picks up this blue sine wave, and it slides it 90 degrees to the left, even though there's a plus 90 in there. The whole thing gets picked up, slid 90 degrees to the left, and then dropped down. And so that's kind of opposite of what your brain is thinking. Your brain is thinking, well, plus 90 would move it to the right. They ask it in a really weird way to make it match that it's 90 degrees to the right. They ask, well, what from this graph back to the normal, what would I have to do? Well, I'd have to move it 90 degrees to the right. But in reality, when I'm graphing these, I usually write down a sine wave for reference, and then I pick it up and move everything to the left 90 degrees. You know what I mean? So a plus 90 inside of here shifts the graph 90 degrees to the left this way. So you pick up the blue one and shift it 90 degrees this way and drop it down. They ask it in a really weird, dumb way, I think. On the graph above, the arrow, whatever, represents the phase difference, okay? Or phase shift or phase angle. For the sine waves above, the phase difference is, and then it says blank to the right. Well, yeah, okay, fine. So they put in a blank. It is 90 degrees. And since they just asked for the difference, you could say it was to the right or to the left. I want you used to understanding that when there's a plus 90 inside here, it moves the normal sinusoid, the sine wave, to the left 90 degrees. If that's a minus, it moves it to the right, however many degrees. Okay? So it is 90 degrees, but they said, just what's the phase difference between those two? So you could say 90 degrees to the right. But I think it gets you set up for a bad habit when you're trying to graph things on your own without a picture in front of you. And yeah, I just think I wish they'd leave the to the left and to the right stuff off, because I think the way that they're asking it or putting it makes you think the wrong thing. Okay, so 24, take a look at 24. See how they ask it, to put y equals, let's write it down, y equals 2 sine of theta minus 60. So what this is going to do, minus 60 is going to pick up this blue one and move it 60 degrees to the right and drop it down, okay? But they don't ask it that way. They say, okay, to get it from that just back to y equals 2 sine theta, we must shift the non-fundamental blank to the left. So they're asking, how do I get back to a regular curve instead of saying, what do I do to the regular curve to get this graph? And so the signed number is negative 60. So here they say 60 degrees to the left to get it back to normal. Okay. And then they said if we put a sign on it, we'd call that negative 60 degrees. That's to get your finished graph back to an original. That's usually not how you're graphing. Like when I'm graphing these, I'm not a very visual person. So what I have to do is I graph myself a sine curve, And then what I do is I pick 1, 2, 3, 4, 5 reference points. And if it's minus 60, I add 60 degrees to each one of those reference points. So that one is now here. This one is now here. This one is now here. This one is now here. And that one is now there. And then I connect those dots. And that is my out of phase one. So this minus 60 actually moved it 60 degrees to the right, okay? It picked up the graph and moved it 60 degrees to the right and dropped it back down. I had to use these reference points just to get it even semi-close, all right? Where I just picked up each one of the sine wave things and moved it 60 degrees to the right, to the best I could, okay? They're asking it in this fashion. They're saying, okay, you have this curve, but I want to get it back to normal. How do I put it back to normal? Well, then I would have to pick up my graph to curve and move it 60 degrees to the left and drop it down. But yeah, I don't like how these are worded. I don't like either one of these going with this. I want you to memorize that when it's minus 60 inside of that parentheses, that that you're actually moving it 60 degrees to the right, not 60 degrees to the left. Okay. All right. And then let's look at one more. The amplitude is as a sine angle, the phase angle with a fundamental sine wave is, and to put the graph of the sine wave in phase. See, I hate that they do it that way, right or left. So on the test, when we do these, I don't know that I'm going to ask you to do that. I might have you graph one and you won't have to tell me right or left. Or I might ask for the phase angle, but I won't hold you to a way because I really don't like how they explained it like this. I'll go over that more during the review so that you're on board. So let's look at 28. They have this, y equals 1.5 sine of theta minus 30 degrees, okay? And so they ask, what's the amplitude? So that's always an easy one. It's the number in front, the absolute value of the number in front. So the amplitude is 1.5. So that means it goes up as high as 1.5 and down as low as negative 1.5. So the amplitude, piece of cake. B, as a sine angle, the phase angle with a fundamental sine wave is, see, now they want you to say negative 30 degrees. You can just say 30 degrees, okay? And then C, I don't like how they ask this. It says to put the graph back into phase with a normal sinusoid, a normal sine graph. We would have to shift it 30 degrees, and that would be 30 degrees to the left to get it back. But let's graph this, okay? It doesn't ask you to graph it. Let's graph this. So if I'm doing this graph, I'll do the sine wave in red, all right? So here's the normal sine wave. And I'll put the degrees down. That's 360 degrees right there. That's 180 degrees right there, okay? This minus 30 actually shifts everything to the right 30 degrees. So this point gets moved to here, 30 degrees to the right. This point gets moved to here, 30 degrees to the right. This one, 30 degrees to the right. This one, 30 degrees to the right. This one, 30 degrees to the right. So if I wanted to graph this one, it would look like that. My sine wave would be here. If I wanted these actual numbers, I'd add 30 to 360. That would be 390 degrees. Okay. I would add 270 plus 30. That would be 300 degrees. Right there. This would be 210. This would be 120, right? 90 plus 30. And this would be 30. So they're all shifted 30 degrees to the right, okay, to get that graph. It is out of phase. It doesn't, it goes down. And now what does the 1.5 do? Well, that just makes the high point 1.5 instead of 1. And the low point negative 1.5. Okay? And so this is what I'd like you to be able to do, is graph it off of, your base knowledge of stuff. So you have to know that minus 30 shifts it 30 degrees to the right, and plus 90 shifts it 90 degrees to the left. So kind of the opposite of what you would think is going on actually happens. And like I said, I don't like how the book asks it, because it is asking you the question, how do I get this curve, the blue curve, this graph, back into phase? Well, then I'd have to pick it up and go 30 degrees left. So that's why they have that 30 degrees left, and that's why they have negative 30 on that. It's a real backwards way to ask, because it's assuming that you'll have the graph already done and then asking how to get it back to normal. That's usually not how we're graphing things. We're taking what we know to be normal and then we're moving that around. And so they kind of send the mixed signals on that one. Okay. Again, I will explain it very extensively on the review so you don't get tripped up on the test on a problem like this, because the homework problems are kind of backwards like that. All right, so let's take a look at 11.4, phase difference between two non-fundamental curves. So this one will not land on the test like this. It's a little beyond. Take a look at 11.4, just one problem on here. Number 31, they already have both of them graphed. They're both out of phase. They tell you there's 120 degrees between the two of them. So they've got the two graphs. Again, don't go off of my graphs. They're not nearly as good as the books. And this one looks like it's down here. And going like that-ish. Okay. Looks like an oscilloscope for those of you that have used oscilloscopes already. Does the 120 degree phase difference appear in the equation or either non-fundamental sine wave? No, because look, it's, they gave us the equations. Y equals the sine of theta plus 30 degrees, and y equals the sine of theta minus 90 degrees. And so you got one shifted 90 degrees to the right, and you got one shifted 30 degrees to the left. So one of them got pulled this way 30 degrees, one of them got pushed that way 90 degrees. Where does that go? Right here. And so there's a grand total difference of 120 degrees. Okay. I think, they went off of the peaks instead of the zeros. I went off of the zeros. So this was at negative 30. This was at positive 90. And so look, we could bust out our sweet algebra skills. 90 minus negative 30. Remember, when we have two negatives in a row, that's a positive. And so we're looking at 120 degrees out of phase either way. So they're 120 degrees out of phase. But they don't even ask that. They say, does the 120 degree phase difference appear in either one of the equations? And the answer is no. Okay. Okay. So hopefully this is making a little bit of sense, a little more sense than how the book kind of messed up on presenting the phase shifts. Everything else is good. All right. And that's it for 11.4.